I'm just gonna continue on the list that I have here of exercises. And today I'm gonna review this Q implementation. Then to continue to do the quizzes as well. See if there's so it's gonna be pretty similar to what the stack was. It's basically the same pattern. You use an internal class to do the main implementation, and then you build a wrapper, which is a view from a view inside of the thing, the original functionality. But basically the same as the ring buffer here is gonna be everything the same, I think. It uses shoe pointers and increases both of them because it uses shoe, which is the part that is kind of confusing, but it works. And has this, I think I didn't format this. Yeah, this is much better. It has a check to see if hit capacity. If the right pointer hits capacity, it just makes it a 0, so it wraps around. And this is not a growable. I think that is not a growable, yeah. If it is full, just throws an error. It's the simpler implementation of the ring buffer, right? And the reads can increase as well because it's a separate pointer from the right. And it decreases the length, I think, on the pop. It's basically the same pattern. When the read pointer reaches the capacity, it wraps around. There's two independent things. Not sure if it's worth it to do the same stuff that I did on the other ones. I think I should ask GPT about it. But when it comes to changing the actual thing, I think it's probably not a good idea. Because like at this point, it's kind of like the same things, repetitive. So there's no principles. But maybe for the details, because I'm gonna have to implement these things once I finish all of them. So maybe to make sure it is a good implementation, they should refactor whatever needs to be refactored. I remember that on the original ring buffer, I had to change this, so maybe this one is bad. There's something of that ChatGPT said, but I don't remember really well how it worked. I know that you should use assume init here, not the reference, but I don't remember what other stuff that it did and why it was kind of, it could be a problem, I think. But I do remember that there was something about this thing here. Let's see if I can remember from memory. I think probably I can't. Maybe it was something. I think it didn't have this from what I remember. I think it was removed this one as well. And I think here was something like this, I think. I don't remember really well. Let's see if the original one has the same pattern. Not the original one, but the first implementation. Also, it was almost the same thing, I think. Huh. That's the... Yeah, so the thing that I did wrong is that I put the read inside here. It's supposed to be here. Yeah, so I remember from memory, but not from understanding. So this is kind of bad. So let me think about why. The thing is, I don't understand what this does. I have to compile with the other one, go to the definition. But I think that it doesn't make sense to call. I think I understand why it doesn't make sense to call the dot read inside, because this is already a pointer. So you don't want to add the value to the buffer. You want to add the pointer itself. So that's why it doesn't make sense to call read there. Then you add. This makes the buffer pointer move to where the read location is at. And then you read that location, you get the value, and you assume that is initialized. But I'm not too sure if this returns a pointer or not. This is from maybe init, because it is the maybe init type problem. It's the read. This is the maybe a mutable pointer to maybe uninit. I kind of forgot as well the point of using this. Maybe it has to do. But I think it's just because if you don't use this, then Rust initialize the value. Like you have to initialize the value. Then using this allows you to allocate, not allocate memory, but or maybe it is allocate memory without having the value. That's the thing. If you don't use this, then Rust doesn't allow you to allocate the memory if you don't initialize it with a value. So this could be dangerous because you can initialize memory without having a value, and then you cause dangling pointer. I think that's probably how it works. Maybe it's worth asking this again. Then does read return? Read's gonna return the actual value, I think. Yeah, so it's from the mutable pointer, and then it returns the value. Read via copy. Now this is one of those situations where I have attributes here. These attributes from this one I remember vaguely, but it's basically it adds metadata, so that's the intermediate representation of the language, has more information to parse correctly. So it's similar to a macro, but it's not really a macro. So like it sits between what the language is and what the intermediate representation is going to be. Intermediate representation is just another language. It's like a simplified version of the language. That's the compiler uses to then compile that into the machine code. But obviously there's other steps before that, optimization steps. So because of this, I think you can't really see the definition of what these things are here. It's kind of annoying. But obviously from the type here, we can understand that it's just getting the value from the pointer. So this gets the value of whatever the add returns. The buffer is that maybe an init pointer. So the add is just gonna move the pointer, the value of the pointer. A pointer is an address, so moves the value of the address to the read pointer. Then it wraps, gets the value from the read, and then it calls this. So this one. So this is probably to check. It says assume initialize. So I don't think it's to check. It's to assume that there is a value there. This is your raw pointer read instead of manually drop into inner so that there is no trace of manually drop mirrors or messages there. No trace of manually drop. And I think it had something to do with the drop as well. The reason to use maybe an init. I think the compiler is just gonna return the type here. It's basically not sure how obviously, but I assume that's what is going on. Maybe this is an interesting thing to ask as well. I'm just gonna ask. I'm gonna ask this one first. There's a bunch of things that I wanna ask there. Oh. And so I assume here I should do the same thing. So just read here, remove the pointer, use assume init. Is it the wrong? So what's up with that? I think it's just the last thing here. Oh, this is the sum value here. What's going on? I guess it's because of the type here. So this one returns the value, this one, maybe if I do the graph here, works. I'll return a value referencing temporary value. By the current function. So maybe this is another thing to ask there. I think like maybe it would work if I did like this. But this maybe if I do like this. No. Hmm. This is weird to me because if it is a temporary value here, then how does it work here? So I guess this assume init is gonna copy the value, maybe? That's the right. Hmm. I don't understand what this raw is either. Do this via raw pointer reading stat or menu draw. But there's no trace of menu draw. So this reads without moving the value. It doesn't pass ownership. That's why. So here is triggering because when I do this, when I use this without, I use the first part without using the assume init, I'm moving the value to the function. So the function becomes the owner of the value. That's why I use assume init here, so you can read the value without getting the ownership. Not sure if there is a risk of doing this, like what the risks are. So I'm wondering if I do assume init here first. It looks kind of weird if I do like this because then it's not the same thing. Yeah, it's obviously not the right thing to do. So I'm not really sure what's the right version of converting this other one into this other format. Oh, fuck. Sure. If I don't use the read, no, but then it doesn't make sense. Just getting the pointer. Not sure if this. I think this it should be dereferencing. So it moves the buffer to the read pointer value or location, and then it dereferences to get the value. Then it turns into assume init reference, which makes sense. But then how would I turn this into the other one? If I use read as I try to do there, it doesn't work. If I call directly, but then why would they use the reference here? Doesn't make sense. I'm just gonna ask ChatGPT. Don't know. I think here it was doing the same as the other one. No, but if it was doing the same, it wouldn't work. Hmm. I think that she was doing like this, but then it would be the same, and then it would be rough here. Then this wouldn't work. Yeah. On return type doesn't work. Yeah, let me try to do the other thing again. The same thing that I did on the other one, but with the other order, but it's gonna hit the same type thing. Because after you do this, it transforms into the other type through that weird cast that we saw there. Hmm. I already forgot what was the original one. Trying to reconstruct, to see if I can reconstruct from memory how he looked after I changed. Maybe it was just with no read here. Then here, no, but I think I tried that already. This, no. Oh, so raw pointer. It's probably similar to this one. But I think I already tried this here. I just didn't have the assume init there. If that's, I think it was just this without the thing. Yeah. No, but this is still going here. If I do assume init there, if I do this, I think it works, but then it doesn't pass here. Oh, it doesn't work? Yes. Oh, S pointer. So the references, then but I think it would be on here. It wouldn't be this, like it would be the same thing. But then, I guess into this, not sure if it makes sense here. Also, it reads after. Pulse reads there. Not sure what's the best way to remember this, but I think that it wasn't like this in the beginning. I'm gonna have to rewatch this video to see how it was initially there, because I forgot. I have to figure out if I can remember these methods. I think once I get to the point where I'm reconstructing the solution several times, it's gonna get easier, because I'm gonna be forced to do basically the same thing that I'm trying to do here, just build on from my own memory. I was thinking about as well adding new solutions and exercises, but it's kind of hard to think about a good way to, because I was thinking about how I'm gonna create an exercise that allows me to basically memorize the main methods for doing loops, for example. But it's kind of hard to think about like a nice one that doesn't, it's not just a simple repetition, but it's also not having to reconstruct the entire class. So I didn't do anything yet.
Arrow reads a maybe uninit t value by value, consuming the slot. Assume underscore init rightward arrow converts maybe uninit t rightward arrow t. Alternative using ptr read and maybe uninit as underscore ptr. You could avoid calling assume underscore init explicitly by doing a raw pointer read of the inner t directly. Rust let it unsafe lit. Const t self debuff add self read as underscore ptr. Read as underscore ptr returns a const t pointing into the memory inside maybe uninit t. Ptr.read reads the value without moving the maybe uninit itself. So the flow is maybe uninit t rightward arrow pointer rightward arrow read t. It's basically what assume underscore init does internally. Keycap to the peak line rust some unsafe self debuff add self read. Assume underscore init underscore ref assume underscore init underscore ref returns a t reference from a maybe uninit t. Equivalent using as underscore ptr. Rust some unsafe self debuff add self read as underscore ptr self debuff add self read as underscore ptr rightward arrow const t ptr rightward arrow converts a raw pointer to a reference t. Behavior is exactly the same as assume underscore init underscore ref. Keycap redoing it without maybe uninit at all. If you didn't use maybe uninit, you would have to guarantee that all slots are initialized from the start. Otherwise, any read would be UB. For example, if your buffer was rust buff box t, you could do rust let himself buff self. Read, but then your ring buffer cannot distinguish between initialized and uninitialized slots, so you have to initialize everything up front or use option T in each slot, which adds extra memory overhead. This is why maybe uninit is commonly used in fixed size ring buffers. It lets you allocate memory without forcing initialization. Summary original rust let it unsafe self buff add self. Read assume underscore init alternative without assume underscore init rust let it unsafe self buff add self read as underscore ptr read original peak rust unsafe self buff add self read assume underscore init underscore ref alternative without assume underscore init underscore ref rust unsafe self buff add self read. As underscore ptr both are functionally identical. You are just manually dereferencing the pointer instead of using the convenience helper methods. If you want, I can also show a version of ring buffer that avoids assume underscore init entirely using ptr read plus maybe uninit that reads more cleanly, so you wouldn't even need to change read assume underscore init. It looks almost like normal rust while staying safe. Do you want me to do that?
Okay, so I think I'm just gonna move on. It looks like it's pretty much the same thing as the ring buffer. Because a queue is a ring buffer. But it's a specific type of queue. It's not really the same thing. So maybe I have to change this. Oh, so did I copy the same thing here? Oh, no. So here it is. I don't like this that much because it's not the same thing like I said before. You're just creating a useless wrapper. Like it's not adding anything. Because hmm, the ring buffer is gonna be limited in size. But what would be the difference, really? Yeah, I think it's basically the same thing, actually. I'm gonna ask this last thing that I'm gonna ask, then I'm gonna mark as okay.
Run memory allocation with alloc. Using maybe uninit to safely handle uninitialized memory. Manual pointer arithmetic. Add, read, write. Ring buffer logic. Wraparound read / write indices. Encapsulating a low-level buffer inside a higher-level abstraction. Q. From a learning perspective, this hits a lot of core Rust systems level topics. You're basically doing what Vectic does internally, but simpler. Keycap 2 ring buffer vs Q now. Conceptually, ring buffer, low level, fixed size circular buffer. Operations, push, pop, peek. Knows nothing about Q semantics. It's just a container for elements in a circular array. Q, abstract data type with FIFO semantics. Operations, in Q, add to back, deq, remove from front, peek, look at front. Guarantees that elements come out in the order they went in. Here's the thing in your implementation. Q is just a thin wrapper over ring buffer. All ring buffer methods already implement FIFO correctly. So yes, for a fixed size FIFO Q, a ring buffer is essentially a Q. The wrapper mainly gives semantic clarity. People understand Q vs ring buffer. Prevents users from calling raw push / pop. You could imagine adding safety checks or changing semantics later. In other words, every FIFO Q could be implemented using a ring buffer, but not every ring buffer is a Q. The ring buffer could be used as a stack, dict, or any circular storage. Keycap 3 pros and cons of this approach. Pros, very efficient. Oh, 1, push and pop. Minimal overhead, raw memory plus maybe uninit. Good exercise for unsafe Rust. Cons / things to consider for improvement. Fixed capacity. You can't grow the Q dynamically. No thread safety. Single thread only. Wrapper adds little. Right now, Q doesn't do anything ring buffer doesn't already provide. Keycap 4 if you wanted more Q-like features, some differences you could introduce if you wanted the abstraction to be more than a wrapper. Dynamic resizing, grow when full. Separate front and back views, like Vectic. Optional bounded capacity checks integrated into Qt. More idiomatic API, implement iterator for dequeuing, into iterator, etc. White heavy checkmark bottom line for a reconstruction exercise. This is excellent. It forces you to think about unsafe Rust, memory layout, pointer math, and FIFO semantics. Conceptually, a Q is an abstraction. A ring buffer is one way to implement it efficiently. Your solution highlights that connection clearly. If your goal is learning low-level memory handling, the fact that the Q wrapper doesn't add functionality isn't the problem. It's a good way to focus on the inner mechanics first. If you want, I can sketch a next-level version of this Q that feels more like a real Q instead of just a wrapper, including maybe dynamic resizing and safer initialization, still using maybe uninit. That would make it a perfect reconstruction project. Do you want me to do that?
Based on the things that is said, I already have the growing ring buffer. I'm considering. I'm just gonna leave it there, just to remember myself every time I go do this exercise. That is basically the same thing. But yeah, I already reviewed this, so I'm just gonna do the quizzes now. Just gonna say this and then do a couple of quizzes and stop streaming. Hmm. Just checking the size of the type you passed there. Hmm. It's basically checking to see if which thing is a zero size type, I think. I'm gonna guess the first one is 0. The clone is probably not. I think. Not sure though. Maybe it's just 0, 1, 0, 1. I think the other two are 1 as well. I don't think our RC is a zero size type. So RC is not a zero size type. And the other ones I got most of them wrong, I think. The fuck? Not sure if I understand this explanation. Are zero size types. So if there are zero size types, shouldn't they be 0 there? Also, it's because of the reference makes it makes it 1. So here is 1 because it is a reference, not. If it was just A, it would be 0. As a setter, and then here is 1 because of the clone, I think. Which one? I think this one is 0. From what I remember. This one will be 1 because of the reference. And then this one is 0, but I don't understand. So this is the one that I have to clarify. The clone, something to do with the implementation there. I think these ones are, yeah. This is the third. Is this one, the clone. So this type has clone. This is this. So when you call clone, you do reference basically, I think. That's the last one here. So when you call clone on this specific zero size type, there's a reference to this empty function. Not sure if this is a function or whatever this is. I know it is a zero size type. So if you call clone on this, it's gonna actually this one is a 1 because of the reference. If you call clone, it removes the reference. That's the last one. think I'm just gonna stop streaming here because I'm already tired. So next time I think I'm gonna continue to do this. Not sure. I'm trying to gauge when's gonna be best to do the conversion there, but I think I have to. I'm basically rewatching. I already rewatched the Andrew Karpathy micrograd video a bunch of times. I think I'm gonna rewatch one more time very slowly to remember how it is. Then after that, I should probably already start trying to convert micrograd to Rust as an exercise to understand, and then start. But I do wanna finish reviewing all of this, so maybe I think I'll keep reviewing this until I do most of them. Maybe I'll do some off stream, and then at some point, I think like probably really soon, I'm gonna try to convert micrograd and then start studying the libraries, the Rust libraries. Probably start with Candle or the machine learning ones to help me start building my own machine learning stuff on Rust. So yeah, see you then.